Hello, everyone, and welcome to our second webinar in Devlogue series. I'm Anchal, and I'm part of the engineering team at Zipy, which is a tech startup. So we have our product built to make lives of engineering teams, especially developers, easier and help them to resolve customer issues in minutes. And while we were developing this product for the developers, we realized that a lot of questions we had and the problems and challenges that we were facing during the journey, they might be common to the community across. And we thought it might be a good idea to start sharing these thoughts and advice from experts and learn together. And that's how the devlog series started at Zipy. So for instance, this one came up as a great candidate while we were having a discussion on data pipelines with Prashant, who is our guest of honor today. So Prashant Dagar is a data management specialist at Google. He's an alumnus of BITS Pilani, has an extensive experience of around 20 years in data engineering and scalable architecture with the likes of IBM, Oracle, and now Google. Over the years, he has helped many startups to think about data and build at scale right from the beginning. So we are very fortunate to have him with us today to answer our questions about data engineering and also guide us through the complexities of building scalable data pipelines. So welcome, Prashant. It's a pleasure to have you with us today.
Thanks a lot, Anjal, and I'm glad to be part of the devlog series from Zipy. And hello, everyone.
Thank you. Looking forward to an enriching session today.
Sure, let's start.
So let me quickly walk you guys through today's agenda. So today's talk with Prashant is going to be all about data, where we will be discussing data engineering concepts, considerations while architecting data pipelines, performance, scalability, cost impacts. Then we also have a few interesting polls coming up during our session. Would love to see all you guys participate. We will have the live Q&A session towards the end of our conversation, but please feel free to type in your question answers in the Q&A section of Zoom, and we'll pick it up towards the end. We do have an interesting swag kit as a giveaway for the best questions, so keep them flowing in. So with that, let's start a conversation with Prashant. So Prashant, to begin with, could you walk us through your journey in data engineering space and what got you excited about this domain and what's kept you going here?
Sure. So I think this goes a long way back in time. Starting year 2000, that's when I started my first job. And since then have been always associated with databases and or data warehouses in some or the other form, either softwares, or we used to have these engineered system. In fact, we still have, which are made to order to run high performance data workloads. So I'm glad and I'm fortunate to go through all the eras of the evolution of data. So earlier it was all relational databases, be it for analytics, be it for transactional workloads. It was dominated by very strong databases like Oracle, DB2, Sybase. And then came the era which was more towards a lot of these large giants launching web applications. Example, eBay, Yahoo, Amazon, right? And then the HTTP web format data types, semi-structured, unstructured, all sorts of data started flowing in. And the data was so huge that there was a need of systems other than the relational databases to hold that data. And that's when we started hearing about NoSQL databases and Hadoop ecosystem, HDFS, Hive, and all those things, right? So that was the second phase where we started storing this huge data with a lot of variety and velocity and so on. And then now we have these intelligent enterprises, as I would call, or intelligent startups, where we want to process everything in real time. Things have got so fast that I would like to, immediately give an offer to a customer or do real time fraud detection, right?
True.
So now we are into a phase where it is getting everything is real time. We want to fetch data in real time, and hence this need of having these different pipelines to capture both batch data as well as streaming data. And we'll talk more about this as we move forward, but this is where all it started.
True. That's quite an impressive journey, Prashant, from where you started and now how things have moved on, how the whole space of data has changed, right? So I'm sure we'll learn along the way in this session. So just to start off, we said this is all about data engineering. So for the benefit of myself and the audience, what really do you mean by data engineering? What all does it comprise?
Okay, so this field again, data engineering has evolved over time, right? We used to have DBAs earlier who used to do most of the work. They used to run SQL reports and all those stuff, right? But mostly it was on top of a monolithic database, which used to serve all purposes. But gradually, as the variety of these sources started increasing, we now have data coming in from SaaS applications, HTMLs, batch files, APIs, NoSQLs, other unstructured data, and the need of the use cases from business. For example, if some business wanted to churn prediction of their customers who land onto their website, right? They would need all this data related to a customer into a central repository on top of which they will do their analytics, AIML, run their AIML models, and so on. This is where data engineering comes into picture. Their primary job at a high level is to bring in the data from all these variety of sources into a central, we can call it a source of truth or a data warehouse or a repository. And then the downstream applications start using that data for their business insights, predictions, and analytics and reporting and so on. So very critical job role. It serves as a bridge between the data sources and then the data scientists and data analytics teams doing all the running all the business use cases on top of this data.
Very interesting and pretty expansive that ways.
Yeah, in fact, a simple formula is data engineering is equal to data pipeline. You might see this in a lot of blogs and all those things. So
Okay.
the job of a data engineer is to create that, the plumbing or the pipeline to move the cleansed data into the single source of truth.
Okay. Great. So we'll get into the details, I think, a little later. Before moving on, I just wanted to ask you, we know you've been helping a lot of startups with their data management strategies. So in your experience, what are the biggest challenges or problems that most of the engineering teams face, especially when they do not understand or foresee early on the demands of handling data at scale?
Absolutely. So for the startups who are very niche or who have just begun their business, a very common challenge which they see is, first of all, there is very less data because the number of users are very less, right? So the
Correct.
problems which we face are very different than startups who may have some data on based on which they can do some historical analysis and even predictions, right? So going back to the startups who don't have enough data, some of the recommendations is to interact more with users, do surveys, interviews, use third party sources to generate the initial data till we have our own set of users, and we do the feature development based on the analysis of those surveys and interviews and the third party data sources, right? And once we start developing the features, our products start getting mature, we'll get more users, right? So this is for a problem where we don't have enough data, right? Then there are startups who have moved into a category where they have enough users. We have enough data to do the analysis on, the predictions on, but the data remains siloed. So there would be several, for example, SaaS applications which a startup would be using. There would be transactional databases like MySQL, Postgres, where the actual business transactions are happening. There
Okay.
may be no SQL databases where they are capturing user profiles, right? Or the data where the schema changes, their product catalogs, and so on. There would be data which would be coming in from social, their handles, their chatbots, right? So
Correct.
how do we integrate this siloed data into a unified source is the most critical problem, and this is the job of a data engineer to streamline it, to automate it, and then to provide a source using which my downstream applications can then start running their use cases. So this is where I think most of the not only startups but even the enterprises who are now getting into real-time data analytics and predictions get into. Once the silo data is unified, then I think post that it's a data science challenge, have the resources, have the models, whether to use custom model or use the cloud services and so on. So I think that's one of the key challenge. If they solve that, then we are done with most of the heavy lifting.
Okay. Yeah, makes sense because I'm sure many of us in this session would be able to relate to these challenges because most of the time when you start with a MVP frame of mind, right? You're not thinking big, you're not thinking about scale, the kind of data that you're collecting, where is it going, and how you'll probably collate it, right? So I think by the time you realize sometimes you're actually started capturing loads of data without proper strategies in place, maybe, right? So yeah, definitely. So follow up on that then. Talking about early stage startups, who are beginning to architect their systems. So you talked about the challenges, but to make a good sound architectural decision, what factors should they keep in mind to overcome these challenges from the beginning, maybe?
Excellent question, Arjun. So uh, there are certain key components of this entire data ecosystem, right? We have sources on one side, then we have this pipeline to bring in the data, then we have a uh, a source in or a target in which we are unifying, in which we are first of all dumping all this data, cleaning it, making it usable for our data scientists, right?
Right.
And generally the best practice here is to do reverse engineering, right? We need to have our use cases in mind, that what's our end goal, what problem are we trying to solve. Is it let's say real time fraud detection? Am I creating my an entire business understanding dashboard, how much business I am doing, what's the revenue, and these standard reports which are there. On top of that, am I opening the system to the entire team to do self-service analysis? They would like, each of the vertical there in my team would like to understand how their team is doing in terms of business. Or is it towards let's say my use cases like fraud detection, right? Or churn predictions like I mentioned earlier. So am I doing predictions there, right? So based on those use cases, we start creating a schema that this is the data which we require, right?
Okay.
Because as they say, any AI/ML model is as good as the data which we have, right? So the cleaner the data, and couple of key properties of a data warehouse, which is the center part of this ecosystem, is it should have a lot of variety of data, right? If I'm going to a library and there is only a book related to, let's say, fiction, I don't like fiction, I would like to read about other stuff, I may not go to that library again. Right? So if people are not able to find answers to their question into the source, they may not come back again. And a
True.
lot of investments have gone bad because a data warehouse was created but was not being used, right?
Okay.
So we need to have a good schema based on what use cases we are trying to solve, and that schema will have data coming in from my sources, multiple sources which we have. And as a data engineer, my job would be to not only just dump the data, but do the appropriate transformations, cleaning, apply. Let's say I want to do aggregations on top of certain columns of a table, and then have a aggregated view provided to my business, and so on. So just to summarize, start with reverse engineering, have use cases in mind, our schemas in the warehouse, we call it as star schemas, snowflake schemas, and so on, a lot of things. come into picture. Those things are the key. And then as a data engineer, I provide all the data to my analytics team to create those schemas and aggregations and other things, which would then be used by my applications.
Makes sense, absolutely, Prashant. So the key is to really understand what you're building, right? And what is the output that you want finally and long term as a
Absolutely.
product. Yeah. So, okay. So on that note, we have our first poll coming up for all of you. Please do take a moment to answer it. So here we're talking about different stages. We want to understand which stage of the data pipeline was or is most complex to build in your teams. Prashant, any insights here? What do you think, in your experience, out of these stages, has been most complex in companies?
I think if the variety of data sources is we have a significant variety of data sources, then ingestion could be a problem because we might need multiple tools.
Okay.
For batch, we may have a different set of mechanism. For streaming, we may have a different set of uh, pipeline and so on.
Okay. So yeah, looking at the results, I think data ingestion, data processing are the
Yeah.
two most complex ones. Okay, so with that, linking it to our next sections, um, when we're talking about pipeline architectures, could you please share with us a high-level data analytics pipeline architecture? How does it look like, and what are the different components, maybe?
A typical architecture would consist of 4 stages. Number one is collecting the data. So we have sources, and then we want to fetch all the data from those sources into my store, right? Uh, while fetching the data, there might be use cases that I need to process the data. For example, there are tools which provide me windowing capabilities. Uh, every 5 minutes, I would like to do an aggregation of the game scores, right? So this is one use
Okay.
case.
Yeah.
Or I would like to remove or join a couple of columns to make a unique ID while the data is coming in real time, right? That's another use case which is very common, right?
Okay.
I may like to trim some of the let's say I would like to split first name and last name into two different columns, right?
Okay.
Or I would like to change. Some people use spelling of Delhi as DELI, DELHI, or there might be other mistakes. So I would like to correct it as the data is coming in to improve the quality of that database so that my models are good, right? So collection, processing, storing, and then using it for AI ML, my business intelligence, visualization using Data Studio or Power BI or Tableau, and other tools like Jupyter Notebooks and all to write my AI ML models, right? So these are the 4 stages which we have, and then there are multiple tools which we use. For example, if we speak of bringing in real-time data, Kafka is one of the most commonly adopted tool which we have for real-time data.
Okay.
It's a write-ahead logging based messaging tool. So you have a publisher and a subscriber model, and you bring in the data in real time, what my customers are doing on my websites, which links they are clicking, which offers they are subscribing to. So all that information in real time can be captured using Kafka, right? There are tools like open, and all these tools which I'm talking about are open source. We'll discuss whether startup should go with open source or managed services later to
Sure.
bring in real-time data from relational databases. For example, I want to move my data from MySQL into a data warehouse. We have open source tools like Debezium. It's we call it as change data capture. As and when data is getting written into MySQL or Postgres or any relational database, Debezium just fetches that data and it has a Kafka connector. It can write it into Kafka, and then we can move it into our data warehouse, right? To move
Okay.
the batch data, we may have different cloud APIs. I can install, Google Cloud or AWS SDKs on my VMs, and then do a bulk copy. We can even use other SCP and FTP mechanisms to move the files for the batch processing, right? So, and then there are, the latest trend is to open up APIs, and we can even do API calls to fetch the data from some of these sources. So this is basically the ingestion part. How do I bring in the real time as well as batch data into my stores? If we speak of processing, there are open source tools like Apache Beam, using which I can do transformations on both real time as well as batch data. We have People might have use Hadoop there to do batch processing, or Spark for real time. There are other tools like Apache Airbyte, or even CDAP, which is again a platform to do data integration. So all these are open source tools.
Okay.
Then we have stores like we have BigQuery in Google, which is very common data warehouse. It's serverless. You just dump the data, and whenever you need, you query it. You only pay for the query which you do. In open source, we have Apache Druid, ClickHouse, other names which you might have heard of. Is These are not open source, but Snowflake and Amazon Redshift. So these are some of the choices for the data warehouses.
Okay.
And finally, we have our once the data is there in a warehouse, I will use it for my machine learning, predictions, BI tools. I can even fetch the data into sheets, and then my team members who are very well versed with sheets, Excel sheets, they can do the analytics in sheets, and there are various other sources. So this is how, generally based on use cases, we select the tools, and these are mostly DIY tools, do it yourself, not managed services. Though we have managed services available on cloud platforms, for example, for Kafka, we have Confluent Kafka, which is a managed service. You don't have to configure it, bother about the underlying infrastructure, security, and all those things. That's taken care of, right? For Hadoop, we have Dataproc. For Apache Beam, we have Dataflow. So there are managed services for these open source as well, which actually prevents you from getting logged in into any particular cloud platform. You can do it hybrid, on premise, on any cloud, and so on.
Okay. Makes sense, Prashant. So you touched upon batch processing, stream processing, right? So it's a follow-up question on that. So when in what scenarios would we use either one of them? So when stream processing, batch processing, and I was reading up, and there is something called micro batch processing as well now that's coming up, which is not really real time, but still almost real time, right? So when do you really use all these?
Okay, so the use of these from stream processing and batch processing would generally depend on the industry you are in. For example, and some of these use cases may be common because most of the businesses would have customers, and they would like to understand their customer well, so that they can get more business out of them, right? So
Sure.
wherever we have B2C sort of use cases, customer 360, is one of the use case where we would like to get deeper into what's the behavior of my customer, what are they doing on my website, on my apps. So we call it as clickstream analytics, right? So it's a real time information on what a customer is doing on a website,
Okay.
and based on that we do real time advertising, or offers, and so on.
Okay.
Another real time use case very well used in the BFSI or the financial sector is real time fraud detection. So they, based on the historical transactions, they would immediately predict whether this transaction is fraud or not, right? There are log analytics which are done, which most of us as engineers would have used if we are using cloud platform. In real time, I can see how my machines are behaving, where the CPU is up, where it is down. That's because the logs are coming in real time into my software, which is the log analytics software, and I get a dashboard on all the analytics which is happening. A lot of manufacturing, customers, especially these electric vehicles, right? They have a lot of sensors placed into their vehicles, and while driving, the data comes in real time from those sensors, and I'm able to see my, how much of battery is left, how much of tire pressure, how is my engine doing, and all those things in real time. Mobile towers is another example who use a lot of these sensors. And then security solutions, so another very critical example of real time, because if I miss that particular point in time, if fraud may happen, or
True.
somebody would hack my system. So
Correct.
on cloud, generally you will see solutions like security command center and all those things, where all the logs and auditing flows into these services, and in real time they will project whether there is any, let's say, crypto mining attack happening or DDoS happening, and then the mitigation is done based on that. In terms of batch processing, I think it's mostly related to bulk data. I may have a lot of files coming in during the day, and during the night a batch starts, and either it could be searching for particular patterns in those files, and you might have heard about banking reconciliations which used to happen during nights, bill generations. So
Right.
these are all batch processing examples.
Okay,
If you
makes sense.
remember, earlier, if we used to transfer money, it would take 24 hours even through the
True.
website, before this NEFT and other things were invented. That's because a flag would have been set as yes for the amount to be transferred, and after 8 hours or so a batch will click in and it will do all the money transfers, reading from the table wherever that flag is set. So these
Makes sense.
are some of the examples of batch processing.
Okay, pretty insightful, Prashant, because most of the time we have options, a lot of options available. Then you're thinking about, what would really make sense in my architecture, right? And the kind of solution that I'm trying to provide. So thank you so much on that. Coming to data storage, so you talked about different tools. Now we have transactional data. We have now when you talk about analytical data, which would be like maybe batch processed. Now, in what scenarios would you look at the storage? Like when I look at OLTP or OLAP, data warehouse or data lake, right? Uh, what are the scenarios, and when should I really go ahead and choose which one?
Sure. This is very critical question, especially for startups, because uh, I have spoken to organizations where they started using, since they were growing, right? They started using MySQL as a transactional database, which was fine. It is meant to run transactional workloads, but then they also hooked into MySQL their BI tools, BI engines, which had complex queries, right? And that's when even the transactional workloads started suffering, because the processing of those complex SQLs would take most of the resources, right?
Okay.
So it's important to understand. It's okay if we are very small, and then we have budget limitations or resource limitations. It's okay to use a single monolithic database for both the use cases. Then now we have read replicas and all those things on cloud to support the read workloads. But as we grow, as the data grows, OLAP storage or OLAP data stores would have different mechanisms to handle that, that scale of data, especially if we
Okay.
speak of several terabytes or petabytes. We need to partition the data internally. There are internal indexes which are maintained, and partition pruning is done so that I'm reading less data. I'm touching storage very less. Most of the thing comes out of buffers and caches, and even the storage is columnar, so that I generally in reporting or in complex warehousing queries, we use very less columns in select clause. never use a star because the data size is huge, and the columns, since data warehouse should have good variety, we have a lot of columns, and if we do a select star, it would actually have a lot of negative impact, performance impact on the system. So the columnar engine is meant for if we have less columns in my select clause, it only hits the blocks where my that particular column data is stored. It really
Okay.
helps reducing the I/O and improving the performance several times. So the architectures are different for OLTP and OLAP. As we grow, we should ideally move our OLAP and reporting and analytics workloads to data warehouses, which I mentioned, right? BigQuery, Snowflake, Redshift. These are all data warehouses which have a different mechanism to handle those sort of data.
That's definitely a good insight, Prashant. Again, the main pointers to consider while selecting different data stores, right? On that
Yeah.
note, we'll have a quick poll for everyone. Since we're talking about data, big data and storage, which of the following is your most preferred data warehouse tool? Any
I would
favorites
go
here,
for
Prashant?
BigQuery since I'm from.
Obvious choice, right? But yeah, a lot of tools that have come up, lot of data warehousing tools available now for everyone, right? To use from a range. So BigQuery, it is. Okay, great. So Prashant, moving on, I have a section where it's very important not only for startups but for any company, security. So when we start architecting, especially multi-tenant systems, right? What are the best practices that we should follow to secure data which is at rest and also in motion? So any pointers there?
Yeah. So if we speak of cloud, one of the best advantage which generally I tell my customers is you don't have to innovate around a lot of such things, right? If I have to secure my on-premise database, it's going to take a lot of tooling and effort to do that. But on cloud, everything is readily available. We should just have the knowledge to implement all those, stuff to make my data secure. And it's not only about basic security, but most of the cloud services do handle, let's say PCI DSS for credit card data, or we have HIPAA, CCA for data warehouses in California.
Okay.
So a lot of these things are taken care of right from the entry point, right? Uh, Using IAM, identity and access management, I can do, who can come into my system and so on. Then we have security groups and firewalls, preventing DDoS. So this creates a periphery around my data sources. We have encryption in transit, encryption in rest, even customer managed encryption keys, cloud platform managed keys, and all those things which come, to secure your data. And finally, there are mechanisms like if I want to redact some of my data, I would like to hide. We are in India, so I would like to hide my Aadhaar card in my tables, right? Or
Right.
my PAN card data, my emails, my mobiles. So we have services like data loss prevention, which can be enabled, which automatically detects these key fields
Okay.
and change it to something else on the fly when somebody's trying to view this data, right?
Okay.
We have role-based access control. Even DBAs won't be able to see, the data. They can only do the administration work. So a lot of such features are there, which one should be aware on how to use those. Engage your partners, your cloud partners, or your cloud platform teams, customer engineers, So this would really enable and help save your data. There are certain best practices around each of these databases. That's also, for example, always create databases in private network. It should never be created on public networks, right?
Okay. Yeah.
Yeah. And there are ways and means in which DBS can then access this database through jump servers and other mechanisms, right, to do the admin activities and patches and so on. So
True.
it's a separate, 2-hour session on how we can secure our data stores, but a very critical piece of information. We have seen customers suffering
Okay.
wherever the gaps were left. Nowadays, it's very easy to get into any data store if somebody has opened it up to 0.0.0/0, right?
Yeah.
So,
Yeah, I'm sure. Yeah, that's true. No, thanks for that, Prashant. Because this is something that everyone is wary of, right? Getting into a trap there.
yep, yep.
So before we talk more, we have a quick poll again for all of you. And this one is on the infrastructure costs incurred by teams and companies. Would really love to see how many in the audience have an answer to this one. I'm assuming that most of the audience today is from the tech side or developers. And what I've generally observed, Prashant, most of the time, the engineering teams or developers, they don't have much idea about what are the costs and the
Yeah,
spend on either cloud or your on-premise infra, right? And the job is more at a CFO or account level.
right.
So, though I believe that making engineers more accountable or at least cognizant of the spend, right? I think for any company, even especially startups, because you have that restriction, right, on the spend. I think you can really enable optimizing costs from the beginning itself.
Absolutely. And in cloud specifically, we need to have good controls around cost. Otherwise, it can spiral out.
True.
I would have gone with the last option here.
Oh yeah, that's a winner too. It's a tie. So how much on an average and do you have your customers at Google spend on managed services maybe?
Yeah, this is it's there is no binary answer to it because we may have startups who have just started. Their spend would be very less, and or they would be on credits. We have startup credits and other mechanisms. There
True.
would be startups who are maturing. Their data sizes have grown. They have a lot of VMs now, multiple microservices, so their expense would be more. But we do conduct, frequent sessions on, we call it as FinOps, where we do certain optimization exercises. Like I mentioned, if a data warehouse is growing beyond a point, then there are certain things, certain knobs which are available there to partition your data, reduce the IO, improve the performance, so that with less number of resources you can do more things. So we do such exercises, and suddenly the cost drops.
So a quick one, Prashant, I will still go ahead and ask you this one. So I think you touched based on it in the beginning. So open source, self-managed or managed, right? Data
Yeah.
engineering tools or services. So which one to pick a when and what is the best combi there?
Okay. So a general rule of thumb is, particularly speaking of, since I am from database field of databases, if you need more control and you have the resources who can manage your critical databases,
Okay.
then I see customers going on with self-deployment, right? They would need root access, and they would like to turn certain flags which may not be available, in managed services. Because in managed services, cloud platforms would retain the control, but they would provide you the SLAs which are published, right? Hence, they take control of the system, but you are owner of your data. Scalability, security, automation, backups, recovery, everything is taken care of for you, right? So I
True.
think control is the first and foremost point, or very rarely those flags which you might hit which you need for your specific application, but then you may not get that into those. Also, some customers would like to try different database. Now we have a lot of variety of databases also. For example, ArangoDB, a managed service of that may not be available, but
Okay.
that solves their purpose of, let's say, graph and social and all those things. So in that case, they may not move to managed service. But wherever we have agile teams, we want faster GTM. I
Correct.
always recommend managed services, and especially now with serverless coming in, it really saves the cost also wherever the workloads are very spiky,
Okay.
because you only pay for the calls and the usage, and then you don't pay anything. So one example which I gave was BigQuery. It's serverless. Only when you are querying the data, you pay for the query, for the amount of data which you scan. And then there are various ways in which you can reduce that scan also. So we have customers whose usage just falls within the free tier only. We give
Oh,
around 1 TB free every month.
okay.
So kind of use cases are there. Then things like Cloud Run, right, which is again a serverless. You can host your stateless services there, and only when you use it. Cloud Functions is another thing which a lot of customers use. Is again serverless. Right. So with serverless coming in, I think managed makes a lot of difference, especially to startups, because we don't have redundant teams to manage or do DIY.
Thanks. Thank you so much, Prashant. Really makes sense to really go, to decide on manage versus self-manage. So with this, Prashant, I will just open up the session for live Q&A. I think we have a lot of audience and queries coming up from them. I have my colleague Karthik here as well. He's the product head at Zipy, and he will help us out with the section. Hi,
Absolutely.
Karthik.
Hi,
Thank you,
Karthik.
Achal, and thank you so much, Prashant, for this insightful, wonderful webinar today. Thank you so much for taking time. And I'm sure a lot of startups today here in the audience will take a lot of insights from what you had to share. So I have a lot of questions coming in from the audience, and I would like to invite Niranjan Prabhu to ask his question directly. So he's asking okay, we are seeing a lot of integrated data solutions today where the database, the ETL, and the visualization tool are all coming together. An example is DOMO. Where do you see this trend going, and what do you feel are the downsides of this otherwise seemingly convenient trend?
Okay. So thanks for this question, Niranjan. This is not a new trend. We have had databases which used to come with even if I spoke of BigQuery. If you see there, once you do a select statement, you can create charts there itself. So we have Data Studio integration built in, using which you can see charts and all those things. So in fact, we have BigQuery also embedded into data warehouses, right? So the whole intention is, once I have a data in my store, right, in my warehouse, I provide all these services so that we don't have to move the data out of the store into another service to do the visualization, or to do modeling and training and all those things. So it really helps me in lot of giving me a lot of performance advantage, because my data stores there, and the engine is generally tuned for the functionality which is provided within that data store. So if you are getting all these functionalities within a single tool, and you feel they are solving your purpose, I think it makes sense to use it. But on the contrary, we also have use cases, because if I speak of, let's say, integrated BQML or integrated business intelligence into these tools, the functionality is limited. It's not a full-fledged tool as Power BI or Tableau. Or if I speak of ML, it's not a Vertex AI platform where I can write my Python code and Jupyter notebooks and all those things. It has limited functionality and algorithms. So depending on the use case, if it is solving, it's best to use that single tool. It might save you some cost as well, apart from performance.
Thank you, Prashant, and thank you, Niranjan, for the question. The next question is from Ashish Nagdev. Ashish is asking if you can throw some light on buzzing data trends like data mesh and data contracts.
Okay. Related to data, a lot of these contracts, a lot of these new trends keep coming up. Like I mentioned, 2000 I started with databases where relational was used for everything. Then we moved to big data and now analytics and ML. And now we have data mesh. Even before data mesh, there were grids which were data grids, or I think IBM started that concept at that time, where we used to have these clusters of data sources and servers to create a grid out of that, right? So again, I would, before using any of these trends, do reverse engineering. Does your use case actually require a data mesh, or can it be simply solved by a simple data warehouse and the surrounding services, right? There are use cases around data lakes as well now, very common, right? People dump in all the raw data from all sources into S3 or in Google Cloud Storage, and they then try to mark various applications onto that single data lake to process whatever they want to do, right? So it completely depends. If you have a use case where data mesh would come handy, then I think go for it. And we have managed services also now coming up for data mesh.
Yes,
Simple
There's,
app.
there's a follow-up question from Ashish. He's asking if is Presto DB already doing data virtualization, which is already part of data mesh domain-oriented architecture, and how does this fit in the data mesh concept?
I have not much idea about Presto DB. Sorry for that. If you can elaborate on what you are trying to do, maybe we can address that.
Sure.
Just post me on my LinkedIn handle, which we'll share, and I'll definitely come back with an answer.
Yeah. The next question is from Priyansh from the audience, and he's asking, does the data architecture depend on the kind of app or data source, whether it's web or mobile, or are these design decisions agnostic of it?
See, generally, web or mobile use cases may or may not overlap. For example, let's take Mintra, right? We have both web and app for that, and most of the use cases would be same from both the sources. They would have same sources, same use cases. So it's I don't think there is too much of variation which is needed in our pipeline in the entire data architecture to address the data coming in from app or the data coming in from a web page. Only thing is the underlying tools which may be attached to, let's say, Android or iOS may be slightly different than what you attach to a web app.
Got it. Thanks,
Oh.
Prashant. Yeah.
So it would
Anand,
mostly
go ahead.
be no. I was just asking. So it would the difference just be on the ingestion side, if it is, and most of the processing and all would still remain the same. You don't need to change the entire pipeline for web versus mobile.
So the frameworks which we use for both, right? So let's say for app we may use Flutter or Firebase, right? Which come embedded with a real-time database or Google Firestore. So the source may become slightly different. Whereas for a web app, I may use a different set. I may have a MySQL attached or some other database attached there. So the source might be different.
Okay.
And depending on the source, my ingestion tool may be different, but the streaming, the entire architecture which we discussed of bringing in the data from these transactional or NoSQL semi-structured data would remain the same.
Got it. Yeah, makes sense. Thanks, Prashant. Yeah, Karthik, go ahead.
Yeah. The next question is from Mike from our Discord server, and he's asking if you can name some popular Google apps where BigQuery is used.
almost all. So we have 9 services which we claim use some of our key services like BigQuery, Bigtable. Cloud Spanner is another distributed database which we use a lot. And the invention of these services was done. They have evolved to handle the scale. So we have 9 services which handle more than a billion users. And to handle that scale of data, we had these BigQuery, Bigtable, and Cloud Spanner invented, and even GKE, which internally, we call it as Borg, the Google Kubernetes engine.
Got it. Thank you, Prashant. And we have a couple of questions from Hemant Pradeep. And the first question is, what are the challenges in analytics or cloud space that have been a stuff of nightmares for you?
I have had customers who wanted to move mainframe data into BigQuery without spending on the tools which are available. So that was a pretty tricky problem to solve. Then there are certain databases, especially licensed ones, which do not open everything for transformation to be brought into target sources. There are challenges around deployment of open source tools. Sometimes if we don't have the right skills within an organization whom we are working with. Example, Debezium is a very flexible tool. It can connect to many sources and many targets. But for if you suddenly get a lot of scale, then it becomes really tricky to handle. So I think if not on daily basis, on weekly basis, we get into some or the other problems related to all these integrations and different types of sources which are there. It's an amazing job, amazing learning, which we get on weekly basis.
Thanks, Prashant. And we have another question where the person is asking whether there are any resources to learn analytics database design, because there are a lot of relational DBs, and where to get started and how to get started.
Okay, so what I would recommend is choose a certification, especially now everyone has almost landed on cloud. So choose one of these certifications. I finished the data engineering certification from professional certification from Google when I joined around 2.5 years back, and that gave me a lot of insight onto how data engineering is handled on cloud, right? So that's one I can personally talk of because I've done it. But I'm sure there would be some certification from AWS and Azure as well if you are using those cloud platforms. So what a certification will do is you'll have a clear path of learning, right? And it would cover everything: how to bring in data from sources to data warehouses, their optimizations, and then the downstream applications. So I would recommend going in for any certification and then taking a course on. Now we have a lot of online digital sources to take tutorials. Google also provide a lot of blogs on these certifications, which will have a lot of knowledge and videos as well, which are easily accessible.
Thanks, Prashant.
If you need more information, feel free to connect me over LinkedIn, and I'll share all the links.
Yeah. So I think we are almost time. So yeah, thanks a lot for sharing these inputs, Prashant. Over to you, Anchal.
Yeah. Thank you so much, Karthik. And thank you so much, Prashant, for gracing us today and talking about a very, very important topic. I think which all of us, all the tech companies face, and giving us a lot of thought-provoking insights about data engineering and working with data pipelines. So thank you.
Thanks a lot, Anchal. And I would also like to thank the audience. The questions asked were of really great quality. So which shows the interest and the kind of mindset the audience has. So thanks again.
Thank you, Prashant. And thank you again to the audience for everyone to participating in polls and asking questions, and hoping each one of you got what you wanted out of this session. You can actually join the community, the Zipy community on Discord if you have further questions, and we'll try to get them answered. I know we are running a little short of time. And as promised, the best question gets a swag kit. So we will keep to it, and we will be announcing the prize on all of our social media handles in a week's time. For all of you, there'll be a short survey at the end of the session also. So for us to really understand if the session was really useful, and if you have any suggestions, so please do fill that up. And if you have any questions about Zipy, please do reach out. So thank you all, and bye until next time.
Thanks, everyone.
Thanks, Prashant.
Take care.